Hey everybody, welcome into my latest live computer build. Today is Friday, January the 18th, 2019. Welcome in and thank you for joining me, and hello to all my friends joining me in the chat. And we're going to make sure that everybody has time to jump into the channel. So I'll just start out by saying thanks to you guys for being some of the first ones in, waiting for the build to start. And we will start it here shortly. This should be a really nice build. I know that the owner of the computer is very excited to watch it. He should be joining us in the chat if he's not already in there. I'm sure he soon will be. And before me lays all the parts that we have for this build. And I'm looking forward to getting it together. And time to keep the variety on the channel moving. I will revisit the router review and the refurbished video concept. I can't postpone future videos. Everything gets scheduled, so if anything can't meet scheduling, it goes back in line, goes to the back of the line, and then it gets rescheduled again, and that's how I don't get too far backed up in things. Everything's got to keep moving forward. And so rest assured that the router review and the Dell PC and the giveaway with that will continue as planned, just a little belated. It has to just go right to the back of the line behind all the other projects that were scheduled after it, and this is one of them. So hello to Stephen Boker, Samuel Ramos, Jens Carlson, Wim VDK, Jim Despositos contributed $2. Thank you, Jim. Thanks for supporting the channel. Stealth Mode and Nelson Contreras, Ben DeCure, Planet Cryos, Brett Kennedy, Peter Brooks, Stephen Bernstein, Edward Green, Corey Wilkerson, Jeremy Clayton, Mark Baggett, Jesse Kirk, A Life of Gaming with Del Dorge, Samuel Ramos, Tony Wallow contributed $1.99. Thank you, Tony. Al Perez, Randy Kendrick, Russell Franzen, Thomas Carter, Michael Collis, John Craig. Thank you guys for joining. Al Perez. There's Marty, Pete Unwin, Paul from Mars is joining us, Roosevelt, welcome, and Rob R. Just giving you guys a shout out here. Ian Scott Johnston. And let us know where you're watching. Tell me, where are you in the world? Put it in the chat. Let me know where you're from. All right, we're just stalling to give people time to get in. We're going to get started here real soon, but I always love to see my viewers all over the world. And it's just a very cool and amazing technology that we have that enables us to communicate with one another back and forth live with this amazing technology. And I'm going to show you how we build that very technology that is a part of what makes all that possible. And you'll be surprised, if you've never seen one of my build videos before, you will be surprised just how easy it is. And furthermore, you'll think twice about how smart people that claim to be computer technicians really are. Which, you know, might make me some enemies, I suppose, when you realize how stupid most computer techs are. I don't want to say stupid, but a lot of computer techs like to call themselves doctors, you know, tech doctor, data doctor, whatever. Put on a white lab coat. It's all pompous and should not intimidate you whatsoever. All right, so let me take a look here in the chat and see what's going on. Another contribution just came in. This is a couple. Let's see. We've got Joshua Bruggerman's contributed $2. Tony Torkelson's contributed $10. And Vibro Steve contributed $2. And Thomas Beckenstow has contributed $10. Thank you guys so much. Thanks for supporting the channel. All the contributions go into buying better equipment, more cameras. Time to start investing in a little more surveillance equipment. I have a lot now, but maybe time to invest in some higher definition. What else do we have? Jan Giddings contributed £1.99. Thank you, Jan. Jeremy Clayton's contributed $2. He's watching from Northwest Arkansas. Welcome in, Jeremy. Thank you for supporting the channel. Frederick Lundholm joins us, I believe from Sweden. Noop is joining us from Flint, Michigan. I grew up not too far from there. Konrad Morchek joining us from Polska, I guess that's Poland, right? DP Challengers watching in Scotland, and Suresh Megos joins us from the Netherlands. Earl Stone says hello from Indiana. Tony Torkelson says he's watching from Idaho. Gary Bickle joins us from Bakersfield, California. And Stealth Mode is in St. Augustine, Florida. Paul joins us from Hampshire, UK. I see Paul Newman has joined us. Welcome back in, Paul. Roby has contributed £2. Thank you for that, Robert. Kabla says joining us from Bangladesh. And Daniel is joining us from Norway. We have viewers all over the world, and thank you guys so much for watching. We've got about 428 of you in there now. I anticipate within about a half hour, an hour, we should see twice that, if not 3 times that, if everything goes well. But regardless, it will go, regardless. And who else do we have? Ken Jung has contributed 40 Norwegian krona. Says, nice work, Kerry. Thank you. And let's see if I missed anybody else. I think I got everybody. Yeah, so thank you guys again for supporting the community that we've created here of like-minded individuals who show support. If you're, I want to warn you, if you're new here and you're not supportive, you will be banned. This is a friendly place, and it will always be a friendly place. So if you're here to poison the well for the community, you won't be here very long. But everybody's welcome, everybody's invited. But remember, we are a community, and we'll do whatever we need to do to make sure we maintain a kind and supportive community where if we have nothing nice to say, we won't say it. Otherwise, we help each other out and we encourage and support one another. That's what we do here. This is a safe place on the internet. It always will be, so long as I have a say. So with that, I think I have stalled enough. I think we're ready to go. We've got, I was hoping for 500 people. We're really close to that number. So let's talk about the parts that we've got here. This is a Corsair 200R case. Now, I've talked about these cases before, that it's my favorite case to use. We don't have the case window and the RGB lighting and water cooling and all the other nonsense that no corporation would ever pay you as a technician to do. This is a good, solid, well-crafted, fairly priced, I would say competitively priced case with a lot of options. It runs nice and cool. It's not a showpiece. It gets the job done, and it has an elegant and timeless look that will still look good 10 years from now versus your case window with RGB lighting and liquid cooling, which is going to be an embarrassment, like looking at a lava lamp 20 years from now. You're going to be so embarrassed by it. So we're not doing that. I mean, you can do it if you want to, but that's not what today's about. Life of Gaming with Deldorge has contributed £4.99. He says, hi, Kerry, love your videos. Hey, thank you, Deldorge. Deldorge. Thank you guys so much for supporting. So anyway, I just want to say in most of the YouTube tech channels that you watch, they're enthusiasts, they're hobbyists. They don't actually work in the industry. If you can imagine being a doctor and you watch a television show like ER or House, you could see all the things they do wrong. It's kind of like that, right? So it's not that I'm saying anything bad about them. I think anybody who does promotes technology in any way, shape, or form is okay in my book. But I just want you as a viewer to recognize the source of the information you're getting. If it's coming from a professional in the industry who does this every day for customers, or if it's somebody who just gets reviews and sponsors and is running a business, a YouTube channel business. Which again, nothing wrong with that. I just want to make sure you understand the way the information that's given to you to determine its worthiness, right? And then of course, always do your own research. Don't believe anybody on the internet. Never believe anybody on it, including myself. Do your own research because it's your hard-earned money. And at the end of the day, if anybody offers you any advice, unless they give you their phone number and contact information for any follow-up problems you have, you shouldn't take their advice. That's all I'm saying. Now, you do what you want, but I'm just saying, if I was you, I wouldn't be taking blind advice from a stranger on the internet. Michael Van Loon's contributed €1.99. Thank you, Michael. And Eric has contributed 15 Canadian dollars. He says, hey, Kerry, thanks for all the videos. Well, thank you, Eric. And thank you, guys. Jim Anderson says he likes lava lamps. Well, they don't really work well as a lamp, and they don't really accomplish anything. But, there's always one. There's always one in the crowd. Maybe I'll make a video on how to make a lava lamp. It's incredibly simple and an immense waste of time. But hey, life is precious and time is short, so why not squander it? All right, so what we're gonna do is we'll start by removing the panels on this case. You've seen me do this a million times before. Again, this is my favorite case to work on, and Corsair has apparently decided to stop manufacturing it. Now, they are still available in the channel, so not in the YouTube channel, in the marketplace channel. They are available through sellers like Amazon and Newegg, but when their inventory is gone, they will not be replaced unless something at Corsair has changed and I haven't been updated. That's the last bit of info. So I have a few of these laying about just in case. And it is the case you will see most often here on the channel because I can't find anything as good, as well thought out of a design for anywhere near the amount of money as this. And when I go into work at it, you'll see how work inside of it, you'll see how easy everything is to work in here. It's so well thought out from behalf of not only an aesthetic standpoint, but also from a standpoint of somebody who actually is building inside. Sometimes it seems like the case manufacturers don't have much of an education with regards to the parts that are going in, that are either looking at aesthetics and they're not really thinking about cooling, or maybe they're thinking about cooling, but they're not thinking of the aesthetics, and then they're not thinking about how difficult or how easy it is to get parts in and out. This covers and checks all of those boxes, unlike any other case that I've seen at this price point, and that's why I like it. This channel has no sponsors. The channel is brought to you for free. The information I give you is free. If you don't like it, you're welcome to leave. It's amazing the entitlement people have nowadays. But regardless of that, you can switch to another channel if you don't like it. I won't stop you and it won't bother me. You're fine. But in the meantime, this is what a professional computer technician recommends for corporations, and this is how a computer professional technician works. And again, don't believe anything you hear on the internet. Do your own verification. Pick what's right for you and enjoy the information. And know that information that you glean from watching videos is not actual life experience. You'll never learn how to ride a bicycle getting on the internet and reading about it or watching videos about it. You'll never know the definition of the meaning of the word hot until you burn yourself. There are certain things we as human beings are incapable of conveying verbally, or for that matter, any other way. They can only happen through experience. And I hope that my channel inspires you to have more experience. Stop being afraid of failure. Tomorrow isn't promised for any of us. We're all lucky to be here on this planet, and so to attack each other is just stupid. It's squandering time. And furthermore, there are lots of other resources and channels on this topic, but I cover it in significant detail, and I show every bolt, every wire, and every screw. So if you've never done it before, you can follow right along with me. And the feeling you get at the end is something I can't explain to you. It's like I can't explain the word hot. Like I said before, you have to really, unfortunately, the only way to learn what it means is to, at some point, have burned yourself. I can't tell you how to swim. You sort of have to get in the water and flail about. But I want you to get in the water. You know, I want you to live a little bit and reduce this imaginary fear and thinking that you're going to screw it up. You're probably not going to screw it up if you follow instruction. And then when you turn that on, you know, and you have that anxiety and you're so worried, oh my God, is this going to work? And you turn it on. The feeling you get when it turns on and it works will make you an addict, and you will want to do this again and again and again. Ask anybody who's ever done it. They're in the chat. Ask anybody if they've, if they were afraid, if they were scared, if they had anxiety. They'll probably say yes. Ask them if they'd ever do it again. I'm sure 100% of them will say yes. And probably there'll be one person that says no, just because there's always a person like that. Well, if everybody's going to do that, I wouldn't do this. All right, so let's get the side panels off. There's two screws. There's one here. You know what? Let me get this lazy Susan from spinning. There we go. One there. Now these panels should be put away somewhere where you're not going to trip over them, step on them, scratch them, or bend them. You know, they're a little, they're not thin, but they're not thick. You know, so you can easily scratch and bend them. So put them away because they're the last part we're going to put back on. Here we go. Panels are off. Now, the documentation that comes with the case, much like most technical documentation, you can just set it right over there. Inside the case, you can see how beautifully laid out and thought out this is for builders, because we have 4 bays for storage hard drives, mechanical drives. We have 4 bays for 2.5-inch solid state drives, and they're all toolless. Just plug in and they click into place. You don't have to use any tools whatsoever, including for installing up to 3 5.25-inch devices. This would be things like a DVD drive or a Blu-ray or a card reader or an extended USB. 2 USB ports weren't enough. You wanted 4 more or 8 more. Kind of like when you run out of outlets and you get one of them surge protectors and it turns one outlet into 6. You can do that for USB, and some cases are eliminating these altogether, these panels, and they reduce the options that the user can have, requiring you to go USB on everything, right? So you can still have a DVD drive or a Blu-ray drive, but you would have to plug it into USB. It wouldn't be part of the case. So in a business environment, this is pretty important. Many businesses today still require DVDs, CDs, a lot of information, especially in the legal fields. They're still transmitting information by mail because they don't feel the internet's a secure way to move critical trial information. And so because of that, many corporations today, especially depending on the field, still require those DVD drives, and they would prefer to have them as part of the computer so that they don't get lost or damaged or stolen by employees. So anyway, again, the corporate environment is quite a different but necessary requirement than, say, a common consumer. And I do my best to try and bridge those two things, because it doesn't seem like there's many people on YouTube that do that. And it's a great experience, by the way, if you're interested in becoming a technician. Working at a corporation and doing desktop support or IT administration or network architecture or database programming, SQL database programming, maintenance, managed service, all of that is a very serious business. A lot of money's at stake. People's livelihoods are at stake. And it's a very serious business, and you'll understand why the lax attitude of the consumer that doesn't understand that doesn't play in the business world. But what plays in the business world is perfect for every consumer. That's the key to it. So let's take a look here. Looks like I missed a couple contributions. Manuel Black has contributed £1. Thank you, Manuel. Was that the other one? Strandberg Tomas has contributed 20 Swedish krona. Thank you, Strandberg. Rob Gurley contributed $5. A shout out to Rob. Eric contributed 15 Canadian dollars. Says, hey, Kerry, thanks for all the videos. I think I got caught up. Did I get caught up? Yes, I got caught up. I think I got everybody. Got everybody? Paul Ducard has contributed $9.99, and thank you to Paul. Okay. First thing I want to do is prep the case. What I mean by prepping the case is I want to put parts in here now that, and let me emphasize, there's no right or wrong place to start. You can start wherever you want to start. I'm going to start by prepping the case. And so that means we're going to put the power supply in, the I/O shield, and any storage. And then we prep the motherboard, and we marry the motherboard to the case. We do the wiring, we install the operating system, we're done. All right, so that's the process for today. So right here, I've got all the parts for the build. You see there's a GeForce GTX 1060 right here. We've got the optical drive, which we're gonna need for case prep. We've got the cooler, the CPU, the RAM, and the solid state drive. That's all going to come up here a little bit later. So I'm gonna move this out of the way. It's important that you have a clear, free workspace so you don't knock anything over or have any issues with getting your hands in where you need to get them without. It just makes life easier to have a nice, clean workspace. So you can have the space behind you be cluttered all you want, but the space while you're working ideally will be a big counter, preferably something you're not going to scratch, or you can lay a cloth or a tablecloth or a towel. And then working on a tile floor and making sure you touch the case periodically. When we do any circuit board handling to avoid any electrostatic discharge. And of course, you could always wear an electrostatic strap if you're still scared. With that, the only other thing I need here will be the power supply. I do need the I/O shield. The I/O shield is unique to the motherboard. So every motherboard in the box, every motherboard comes with an I/O shield that matches it, and they're rarely interchangeable. So all I'm going to do right now is I'm going to just dig in this box for the I/O shield. I'm going to show you what that looks like right here. That's the I/O shield. And we'll get you some better shots as we proceed forward. I don't have a camera operator. I am the director, the producer, the script writer, the talent, the marketing guy, the sales guy, the promoter, the editor, the video description administrator, the YouTube administrator, the moderator, whatever you want to make up, I'm it. So bear with me. I do the best I can as a one-man band, and so ideally, as the channel grows and as contributions come in, perhaps one day I will make it into a studio and actually get a camera operator and a sound person and a mediator or a liaison between me and the chat room. We're not ready for that yet, but that's okay. If it happens one day, it will, and if it doesn't, it doesn't. In the meantime, this is how we do things. This is the I/O shield, and the I/O shield, like I say, it comes with the motherboard. And you can see the ports are unique in how they are aligned and spaced, and which ports are here and what size and where they're located. Unique to this particular motherboard. Now in this case, we're always going to install it with the word prime here facing up. If your I/O shield doesn't have any words on it, but if you see a bunch of little holes like this, those always go towards the bottom. No tools are needed to install this. You'll reach into the case like so, and it's just going to snap in. It's a little difficult sometimes because when you get two of the bottom corners in and you go to push the two top ones in, then the two bottom ones often will pop out. So sometimes, if you're a first-time builder, this can be one of the toughest parts of it, or frustrating parts, because every time you pop one corner in, another corner pops out. And so some people have to use two hands. Also on cheaper cases that are from other not as reputable manufacturers, this cutout may not be as precise, and it may make your installation more difficult. If all you're looking to do is buy the cheapest parts you can buy, you probably shouldn't build a computer, because that will be one of the most difficult and finicky computers to build. Also, if you buy the most expensive computer you can buy, it will probably be a very difficult computer to build. It's sort of like if you buy the cheapest car you can buy, it's probably going to be rife with problems and reliability issues. If you buy the most expensive car you can buy, like a Ferrari, a Lamborghini, a McLaren, an Aston Martin, you will probably, well, let's just say none of those cars are known for their reliability. So what we're looking to be is in this great big middle area of consumer product that is from reputable manufacturers. It's not the cheapest, it's not the most expensive, it's kind of a best bang for the buck. And so long as you buy good quality parts and you follow my steps, 99.9% of the time it's going to be just fine. And it's a very strict rule here for me because I'm running a business. So if my business can make a little extra profit by buying cheaper parts, but then it damages my reputation with the customer because it's not reliable, the customers lose faith in my ability, I lose my business, I'm out of business. Or if I use cheaper parts that I have to keep coming back for warranty, I lose money on warranty. There's not a lot of money to be made in building computers. I do it because it's a passion. I enjoy teaching people how to be self-reliant, and I enjoy the feedback I get from viewers all over the world of every age, gender, religion, thinking they couldn't do it, people that are disabled, people that are elderly, people that are anywhere in between, of parents working with children and bonding with their children over a build. That's why I do this. Let's be clear. So that's the I/O shield right there. Now we're going to put the optical drive in. So an optical drive is basically any drive that uses a laser to be read optically. So that would be a CD, a DVD, or a Blu-ray. Now, many gamers and consumers will falsely believe that the world revolves around them and that everybody does the things they do, and they don't. As I mentioned, corporate America, which dictates our quality of life, quite frankly, still requires these. Most of corporate America still requires these. And if you want one, fine. If you don't want one, that's fine. You don't have to have one of these on your build if you're choosing to build a computer yourself and you think you're just going to do everything online. There's a good chance you don't need this. Also, you can get one with a USB for about $10 more. They're not expensive. Something like this runs about $20. So I'm of the school, it's better to have it than not need it, than the other way around. Randy Kendrick has contributed $9.99. He says, have a Coke and a smile. Cheers, Randy. Now on the front, we have these little plastic panels right up here. And all I have to do is reach my hand in and just go, see ya, right? This is our optical drive. Anything that is going to be exposed on the front gets installed from the front. You do not install anything you can see from the front from the back. You always put it in from the front. Just line it up. Don't struggle with anything. Don't force anything. If everything's not fitting, it should be snug, but you shouldn't have to force it. We're not working with glass, but they are electronics, right? So respect it as such. And there's a little lever, pull that back, and it just locks into place. Well there, we've already installed the IO shield and the optical drive. Are you intimidated yet? It's pretty easy. Now we can also use a screw that comes with the case to secure this if we want to. Because this has to be shipped and it's going to go 2,000 miles across the United States, I'm definitely going to put screws in here to lock this to make sure it doesn't break free in shipping. But if it's something I was building for myself and it's not going anywhere, then that's not necessary. I will fall back on better to have it and not need it than the other way around. So I would probably still put a screw in it just because there's no harm in doing it. But there is potential harm if you don't. But that's a decision for you to make. One of the things that's important to me is that you don't act like a robot. It's important to me that you use your own judgment and your own cognitive skill to understand why I'm doing what I'm doing, so that if something doesn't align with what you're doing precisely, if you understand why I'm doing things a certain way, then you can come up with your own critical thinking to determine confidently how to proceed without just being a, mindless robot following instruction. I don't want you to be a soldier. I want you to be an independent thinker, and I want you to realize that this is all very simple, right? So if you're not getting something, just take a step back. And of course, there's a great chat room here. If you have any questions at all, there are people in the chat that would be glad to help you and help answer any questions you have. And I do my best to address any questions that I catch, but it's very difficult for me to do both things, at the same time. So right now, the next thing I want to put in is going to be the power supply, which I have right here. Now, the power supply, this is a EVGA 700BR. There are two different kinds of power supplies. There's modular, well, three kinds: modular, semi-modular, and fully modular. What modular means is the cables can be attached and detached. Semi-modular means some of the cables can be attached and detached. And this power supply is not modular in any way, shape, or form. The reasons why people like a modular power supply are generally looks. They generally are going to have a case window, and they're generally going to be consumers. Businesses and people that are not using their computer for gaming and they're not interested in what the computer looks like, they will go with saving their money and getting the cheaper power supply that's not modular. I've run into companies and even individuals where they got the modular power supply, and then a year or two later, when they needed to do an upgrade, they couldn't find the cables anymore. These cables will always be attached to this power supply, and all the extra cables we don't use will be nylon zip tied, so that any time in the future, whether it's next week or 10 years from now, we don't have to go hunting for those cables. They're already attached, they don't come off. So pros and cons, both financially as well as benefits and potential consequences, and decide, of course, for yourself. Now, if you're looking to build a computer and you're not quite sure what parts you should use, the worst thing you can do is go on the internet and ask somebody for free advice. there's one exception, and that is there's a person that joins us in the chat room regularly, and her name is Catherine Anna Hauserman. Now, Catherine, she lives in Colombia, of all places, and she enjoys asking people, you know, doing the interview and asking people, what's your budget? What do you intend to use the computer for? Does the case size matter? Do you need it to be portable? Do you care what color it is? Do you want a case window? Do you want RGB lighting? You know, how do you intend on using the computer? What games are you playing? How many screens will you have? What are your future plans with the computer? And after this exhaustive interview is conducted, then and only then can she recommend any parts to you. Now, she does this for free. All she wants in return is a thank you. All right. So there are people that have been very rude to her, people that have been very demanding and very they seem to have this sense of self-importance and entitlement. You're not going to get too far. All right, it's free. It's free. Please don't abuse it. Please do not abuse her. She's a great person and she enjoys helping people. And the parts list that she puts together, how do they compare to mine? Well, she puts this parts list together. That's how it compares to mine. Yeah, she makes parts lists for me. It saves me time. I just look through it, I'm like, yeah, this checks all the boxes I need, and she does it amazingly well, and it's hard to believe anybody in their right mind would do that for free. So a big shout out and a thank you to Catherine Anna Hauserman. I don't know if she's in there today, but she rocks. As do many of you as well, don't get me wrong. All right, let's get started. You're not supposed to use a knife toward yourself. That's bad form. Boy Scouts 101, man. Now, these EVGA power supplies I like because they have a great warranty on them. They are very aggressively priced. My experience with them is that they've been very reliable, just as reliable as anything else I've used in power supplies. They have the power efficiency ratings, which means that they have to conform to the standards for 80 plus, meaning that it won't cost you as much electricity to run your computer with an 80 plus rated power supply. There are numerous types of 80 plus efficiency ratings, and of course, as the efficiency rating goes up, the price of the power supply goes up. I feel bad for the marketing companies that have to try and convince you to spend an extraordinary amount of money for a little tiny bit more efficiency, but they don't seem to mind doing that. But be that as it may, if you had a company with 500 computers in your building, power supply efficiency is it can make a pretty big difference in your electric bill. For one person in a house as a consumer, whether or not your power supply is efficient or not may not make much difference noticeably on your electric bill. However, it is built to with higher quality components than any non-80 plus power supply. So all I'm trying to say is you don't have to use this power supply, but you should look for one that has an 80 plus rating. Regardless of what that 80 plus rating is, that 80 plus rating signifies that that power supply is superior in quality than any other power supply that does not have the 80 plus rating. Bingo, done. Inside this box, now this is packed a little unusual. Usually power supplies come in long, narrow boxes, but EVGA has figured out how to get this thing in the square box, which is weird. We've got a power cable. Your computer's not going to work very well without one. It's like gas for a car. We've got some screws for installing power supply, and then we've got the power supply itself, which is right here, with some bubble wrap, which we will take off. There we go. And you guys can have that. What a weak throw. Holzman's on the mound. There's the wind up. It's a good build up though, right? These are the instructions. Unless you speak Techese, they can go over there. And the box, well, we always have a place for our boxes. We put these right over there. All right, now this is the part we actually need. All right, this part, don't Don't be throwing this around. It'll crack the tile on your floor. This has a fan on the bottom. Now this fan, what this fan does is it pulls air in. It doesn't blow air out. It pulls air in, and then it gets forced out through the back. And if you notice on the bottom of this case, we have holes right down here. And these holes are what's going to allow that power supply to breathe, and that's why there is this filter that you can take and blow the dust out of it. If you place this case, you see there's not a whole lot of room here. If you place this case on thick carpeting, you will suffocate your power supply. You will have a very expensive vacuum cleaner. Now, if you do have carpeting that's thick, or any other concern that your power supply is not being having good airflow, simply just take some blocks or some books or some magazines and lift that case up and set it on that, keeping this area free to breathe. Nothing that gets drawn in from the power supply goes in the case. This has nothing to do with the cooling of the case. This is strictly cooling the power supply. It is possible to turn the power supply around the other way and bring the hot air from the case in instead. But if you do that, when you're working on your case, if you drop a screw in there, that's not good. 120 volts is flowing through here, and that's the last thing you need. The other thing is all your cables will be coming out towards the open panel here, which makes it ugly and difficult to work on. It's much, much easier for these cables to be up against the back tray. You can do it either way, it will work either way, but this way makes the most sense. Now, I'm simply gonna grab the power supply here, and there's a little flap right back here. I'm not sure how well you guys can see that. And I'm just gonna set it underneath that flap, and it does require a little bit of wiggling. Once it is flush and back up against this tray, I slide it right towards the back, and as you can see, that's our power supply installed. All I have to do now is secure it into position. Now the case comes with screws, and I'm going to show you that in just a minute, but I'm going to use the screws that came with the power supply instead. The only reason I wouldn't use the screws that come with the power supply is if they don't match the color of the case. And not all the time do all case manufacturers give you screws that match the color of the case. I don't want to put silver screws on a black case, and I wish this I/O shield was not silver. It doesn't have to be black, it could be gunmetal, it could be gray. I just don't know why they went with silver, knowing that people don't buy silver computers, generally speaking. You'll see me using this cordless screwdriver. This is a Panasonic EY7410. This is my lightsaber, young Padawan. This is my favorite. If it's wrong for a man to love a screwdriver, then I never want to be right. This has probably saved me repetitive stress syndrome, carpal tunnel syndrome, maybe not specifically this, but tools like this. What makes this tool so far superior than others, one, it has a lithium-ion battery, so I don't have to charge it every day, and far from it, maybe once a month. Two, it's got multiple speeds, which other screwdrivers have. This has a clutch on it. Again, other drivers have a clutch, but this is an auto-off clutch. The difference is that when this screwdriver hits the torque setting that I've set, it shuts off. It doesn't make that terrible sound, which is also not good on the components inside. Over time, it wears down. So this saves battery life, it saves the noise, and it lets you know for certain that the screw has been tightened to the torque specification that you have set. So up here you'll see it says 3, and I can twist this around to choose other numbers. So I'm going to put it on 3. There we go. And then there's a switch here for high speed and low speed, and there's a switch here to lock the screwdriver. Locking it means the motor won't turn, so you can turn the screwdriver as though it were just a normal everyday manual screwdriver. It's funny to me they call these cordless screwdrivers. Isn't a screwdriver you turn with your hand also cordless? All right. So let's get these screws installed. One screw goes into each corner, but not necessarily in the literal corner, in the area of the corner. So for example, one's going to go here, not up here, not over here. It goes right there. This one is offset by about 1 inch from the corner, like there. This one goes directly below, right there. And finally, this one is going to go right here. You'll see I start all the screws before I tighten them down. And the reason I do that is that if any of these screws are not lining up properly, I can reach in this case and I can wiggle this power supply around as I need to get everything to align. Once they're all aligned, now I can go ahead and tighten them down. You hear that screwdriver shut off? That's it. Now, I personally like to take the power supply screws and tighten them down just a little bit more than that lower torque setting that I have, only because it's so big and heavy. If it were to break free in shipping, it will destroy the internal components of everything that was inside. So if you're not shipping the computer, that's not critical to you like it is to me. Once again, there's a difference between the way a consumer does something and the way a business does something, and it all makes sense. And of course, choose whichever way is appropriate for you. Whatever makes you the most comfortable is the right way for you, but not necessarily for anybody else. Okay? All right, so now we've got, with the power supply installed and the I/O shield and the optical drive, the case is pretty well prepped. I kept talking about screws. Where are these screws? Well, every case you buy will come with the mounting screws for the hardware the case supports. Not all cases support the same hardware. So because of that, every case has to come with the screws that match what the case is capable of. So here, in one of our hard drive bays, there's a box. And by pulling the release lever, which is right here, I can pull this box straight out, right? And in this box, we're gonna find all those screws I was talking about, along with some free nylon zip ties. It's always good. You'll never have too many of these. And then the rest of this box. Oh, no, there's still one more zip tie in there. All right. The rest of this box is empty. Now, the screws they give us, we're not going to be using all of these. Don't feel intimidated by all these bags of screws. These screws assume you're going to fill every slot in every bay. Nobody does that. Like, if you're the kind of person that does that, medication's available. All right. So anyway, no, seriously, this is these fan screws. We're not using those. These standoffs, we probably will not need those. Then we have some regular mounting screws for optical and regular mounting screws for the motherboard. And then these are more fan screws. We're not adding any more fans. So these screws and this power cable will go in the motherboard box to the customer, so that in the future, if the customer wants to adjust, adapt, repair, or upgrade, just because we're not using them today doesn't mean we're never going to use them. So the customer gets those. These cables, we're going to just leave them wrapped up so they stay out of the way for right now. And I'm going to move this case off to the side so we can start prepping the motherboard. Now, before I continue, I know there's a lot of familiar faces in the chat, right? I know that many of you have heard all of this over and over and over again. However, we always have new viewers watching, and so before I move, or as I'm setting up for the motherboard prep, if you have any questions about what I have done so far, please ask them in the chat now, and in this interim, I'll do my best to address any questions you have. So to prep, what I need next, I need to get the motherboard ready, which is going to be the board, the chip, the RAM, the SSD, and the cooler. That's what's going to be required for this step. Nick Poverman says, my screws are in the original motherboard box in my closet in my office. See, I love when people know exactly where that stuff is, because it's the kind of stuff that you don't need very often and can very easily, not be thought of and forgotten. And when you need it, you're going to be upset because you often can't just go to a hardware store and find those kind of screws. You'll probably have to get with your case manufacturer by contacting their support and then ordering more screws. And you might find out it's faster and, well, it's not going to be cheaper, but it'll be much faster to just buy a new case, unfortunately. So put that stuff away for your own good. There's 913 people watching live. Welcome in, everybody. Did you do any math to figure out how big of a power supply you need? I do the math in my head. Basically, computers don't suck up as much power as people on the internet would have you believe. If you don't believe me, you can go to Amazon. Well, there's other places that sell them, and you can buy one of these. This is called a kilowatt, and what it does is it'll measure the amount of power being pulled from it, and it'll show you how many volts are being used. That's never going to change, right? But it'll show you the watts, the actual amount of consumption. Most computers that I build, just standard ordinary computers, are going to idle around 100, 150 watts. And when you ramp them up, they're going to probably go to 300, 400 watts. So unless you're building something extravagant, going 600 watts is probably more than enough for pretty much any build, unless you are adding multiple storage drives or multiple video cards. That's it. It's really that simple. You can also go to numerous websites, from Newegg to just searching Google for power supply calculator. If you just type in the words power supply calculator, EVGA, even, who makes power supplies, has a power supply calculator. They're all free to use, and they'll ask you which components you're using. I also believe if you put your parts list together on PC Part Picker, I believe they also estimate the amount of power needed. But I also think you need at least 20% more minimum than what you need. So if you need 400 watts, having a 600 watt power supply gives you a lot of overhead, and that's a lot more than 20%, and that's okay. But you need to also understand that if you go with listen, the companies that make power supplies, they're happy to sell you stuff you'll never use. For example, you see a lot of people driving off-road, capable four-wheel drive SUVs, and they never take them off-road. Right? There's a lot of Humvees running around and a lot of Land Rovers, very expensive off-road capable vehicles that never ever never get off pavement. They're happy to sell you that. There are people that will buy Dodge Hellcat Demons or Exorcists that have 1,000 horsepower that never ever use more than 200 horsepower. So think of it that way. Why would you buy a 1,000 horsepower car if you never ever push more than 200 horsepower, ever? They'll sell it to you, but why? So in the same way, power supplies, they'll say an 1,800 watt power supply, 1,500 watt power supply, but there's very few homes in America that have the amperage on a circuit to support that. So how does that make any sense? The amperage of the average circuit in America in a home is about 15 amps, and that's for everything plugged into that circuit. The circuit isn't just one outlet, it's several outlets and everything plugged into it. Your TV, your monitor, your modem, your router, your printer, all added up together will deliver 1,800 watts maximum through that outlet without throwing a breaker. So it doesn't really make sense for most people to need 1,000 watts or more on the power supply, because there's a good chance that if they actually drew that much from the wall, the circuit breaker would get popped. So think about that. Just because it's available and you can afford it doesn't mean you should buy it. And if you're curious how much power your laptop is drawing, or your microwave oven, or anything that plugs in, your television, these are about 20 bucks on Amazon, and they make all different kinds of them. This is a real base model, and you can see exactly how much power things are drawing. And you'll be surprised how much power things draw when they're off. Your television never really turns off. Your computer never really turns off, not a desktop. When you shut it off, there's just a little trickle of power, these little vampires, if you will. Same with your cable box from your cable company. It never shuts off. Most modern electronic devices go into a low power standby mode where they're still sucking a little bit of power, but you'll know exactly what they're drawing with one of these. And this is called a Kilowatt Model P3, and it's fascinating to see with your own eyes exactly how much power you're using, so that when these people on the internet tell you you need, 18,000 watts, 1.21 gigawatts, you'll say, dude, that's all you're gonna say. Dude, really? Spent a long time answering that question, didn't I? All right. Just looking through the comments to see if I've missed anything. If there's any other technical questions in here. Wim says, I guess I need medication. I have no free storage slots on my board. That's funny. Neil says, every time I watch your vids, I feel the need to build a new PC. Yeah, I don't think they have help for that. Sean says, Carrie, the Corsair 200R case was my case of choice when I built my PC 6 years ago, and I still love it to this day. Easily able to switch stuff out, and it's super roomy. Absolutely. And it doesn't look gaudy like a case with a window and RGB lighting, you know, is going to look in time. It's going to be like looking at an old high school yearbook photo. It's going to be very embarrassing for you. What else? Carrie, how much does such a case? I'm not sure I understand that question. Hibernate on a desktop is about as useful as a screen door on a submarine. All right. Carrie, which is better, a horizontal or vertical CPU heatsink? There's no such thing as better. You pick whichever one's right for you. Do your own research, look at the reviews, and decide accordingly. Use the, you see what I build, so anything you see me build, I obviously condone. If you don't see me build it, there's probably a reason why. But ultimately, do your own research and decide what's right for you on price, reliability, ease of installation. I have coolers that can be installed horizontally or vertically. I've demonstrated that before. That doesn't change anything as far as effectiveness. The actual design of the cooler is what impacts its effectiveness. The actual manufacturing process, the materials that are used, whether it's vertical or horizontal, it can impact things like clearance issues horizontally or vertically. And depending on the case you've picked, the RAM that you've picked, the height of the RAM, the height of this heatsink, it's best that you either follow along with somebody with the same parts, or if you choose to go out on your own, that you talk to somebody who can assist you with that. But there is no such thing as better. Is chicken better than steak? Nobody can answer that. You can answer it only for you, and nobody else can tell you what you like. No one else can tell you what you feel, and nor should you assume anybody can feel what you feel, the way you feel it. You shouldn't assume that when you look at the color red that other people see the same color. You can identify that color as red, but they may not visually acknowledge it or recognize it in the way that you do. So I think one of the biggest mistakes people make is they think that everybody's like them. Nobody is like you. We're all unique, just like everybody else. All right? Now, let's prep the board. So here in the motherboard box, I'm going to pull this out. This is the board in an anti-static bag. And then in the motherboard box, we've got this piece of cardboard that can go over there. We've got a little bridge for connecting two video cards together, which nobody does anymore. We've got our SATA cables. We've got what looks like an M2 extension and an M2 screw and standoff, which we're going to need during motherboard prep. We've got our instruction manual here, and we've got our driver disc there. And everything that is parts that we're not gonna use, like those extra screws, the power cable, we're just gonna put those right in here. So we have everything in one place, so we don't have to go looking around for it, and we'll keep it in here. Anything left over, like that little plastic panel I popped out. You know, if the customer ever wants to pull this out and fill the hole back in with this panel, they'll have it, right? They may never ever do that, but the panel either goes there or it goes in the garbage can. So as long as you have the case, you got to keep the panel. Now, I like to put the motherboard on the motherboard box just so I don't scratch up my counter. The anti-static bag, this is where the people on the internet crack me up. People who lack proper education think things are possible that are impossible because they don't have the education. And so rather than get the education, they'll tell you, you know, conspiracies, or they'll tell you, they'll parrot back things they read on the internet as though it's the same as getting a proper education in, for example, electrical engineering. It's not the same thing. So, like the static bag, the reason they put the motherboard in a static bag, an anti-static bag, is anything placed in this bag is going to be free from static, right? So they say, for example, don't build on this bag. Well, you can build on the bag. There's nothing about the bag you can't. It's just silly to say you can't build on it. So the motherboard's only safe inside of it, but it's not safe outside of it. I mean, come on, use your head. This is just a bizarre, here's where the miscommunication is, and here's where the uneducated often give bad advice with regards to the anti-static bag. What they think is, because the motherboard manufacturers have this boilerplate statement that says the bag offers you no anti-static protection when you build on it, neither does this cardboard box, neither does anything you place the motherboard on. I mean, unless you place it on an anti-static mat. The reason this works for anti-static only when the motherboard is in it is the same reason a jail only works, or a cage only works, if you're inside the cage. If you're outside the cage, it's still a cage. You understand? You're just not in it anymore, so it's not effective unless you're inside of it. Think of this as a cage to protect against electrostatic discharge. That's all it is. And once it's out of the bag, it's out of the cage, and now is susceptible to accidental ESD, or electrostatic discharge. It's not that the bag is conductive. We can put a meter on this, a voltmeter, and we can measure. There's actually less voltage measured on this bag than in the palm of your hand. So that's why you have to understand some of the statements that are made by people on the internet are so, they come from a place of good intention, but without education, without scholastic academic education and such. They misunderstand the information that they read or they were told, and then they parrot it back out, and then it's harder for the people who know to educate. When somebody thinks they already know something, it's harder to teach them. It's harder to unlearn. It's much easier if you were learning it right out of the gate. And again, don't take anybody's word for anything. Look up Faraday cage, if you'd like, on the internet. And you can also read about anti-static bags, and always consider the source of the material, where that material is coming from. So if anything that you're reading is opposite of what I'm saying, consider where it's coming from. If it's coming from a university, it's probably trustworthy. So anyway, we don't need to build on it. Again, it doesn't matter if you do or you don't. And it's weird the things people on the internet get upset about. But apparently that's the time that we live in. And I've got another camera that I'm going to put here to give you guys a better close-up of what I'm doing here. So let me grab that and bring it out here. It's turned on. Come on, baby. Let's go. Let's go. Work with me. Here we go. All right, now I'm going to switch your angle view so that you can get a nice clear shot of what I am doing. We're still talking about electrostatic discharge in the chat room. Basically, the electrostatic discharge is much more of a concern in the manufacturing of the components. Once the components are soldered into a circuit, the circuit has grounding points on it already. So it's pretty hard to cause electrostatic discharge, but you shouldn't try, that's all I'm saying. I wouldn't be overly confident, right? So as long as you take some precautions, very minor little precautions that you're self-aware, it's not likely that there's a lot of anxiety again over what ultimately amounts to a lack of education. Most anxiety comes from fear. Most fear comes from ignorance. It's you're scared of something, but you don't know what it is, and it's very unproductive. And something, in my opinion, people in this world need to get a handle on. I don't want to change the subject, so let's get over to blend. Let's blend. There we go. This is looking better. And then let's zoom this in a little bit. I get some light reflection here. Hold on a minute. Let me just get this aligned. That's a little better. What is happening with my... I guess we'll just do... Maybe I do that. Maybe that'd be a little easier, Carrie. All right. Everything's backwards. Hold on a second. Come on, where are you? There it is. All right. Maybe I can reduce some lighting to get that reflection down. More? A little too dark. I guess we're going to deal with the reflection a little bit here. And let me see. Let me see. Nothing. Okay. So, there's no real right or wrong place, again, to start with prepping the motherboard. We can put the RAM in first, or we can put the CPU in first, we can put the storage M2 in first. No right or wrong way. I'm just randomly deciding how I want to do it. Every part you install is one less part to install later. And I do recommend you slow down, take your time, don't rush through this. Enjoy the process. It is something you are going to want to do again. So savor the whole process. I'm telling you, it's it is absolutely fulfilling. This chemical release in your brain that you get is something I can't describe. And it's very addictive to want to feel fulfilled. So knowing that, don't be in a hurry. If you feel as though you're getting frustrated or you feel like you're just really anxious to use it, I would suggest you take a break, go watch some TV, come at it calmly, because the CPU I'm dealing with here is several $100s. And I don't want you to just slap it in there all willy-nilly and potentially damage something because you're anxious. Be calm, enjoy it. All right, so I guess what I want to do first is I'm going to pop the CPU in there. You see I've got the Core i7. It's the i7-8700K. This is the enthusiast chip. It's a very powerful chip. It's fast. It's still consumer though, so we're still not dealing with Ferraris, all right? We're not dealing with finicky parts. We're right at the top end of best bang for the buck. And then we'll open this up, and inside is our processor and documentations. And this is a little sticker. And if you put this sticker on your computer's going to go faster, which is not true. But people seem to think so. I mean, you ever seen a NASCAR race with a car with no stickers on it? Clearly, those stickers are required for those cars to go that fast. Sarcasm is implied. Now on Intel, when we talk about Intel CPUs, they sell them with and without factory coolers. If the CPU has a K designation after its model number, that means that it's been clocked 10% higher. It also means it's overclockable, and it also means it doesn't come with its own cooler. because it's considered to be an enthusiast chip, and that for an enthusiast, you'd be far too much of a snob to ever use a factory cooler, so they're not going to waste their money and send you one. Again, generalizing, but that's the way it is. The people who generally buy the K CPUs are more snobbish about their parts than most computer owners, who, if you ask an average computer owner, what cooler do you have, they'll look at you and go, what? So if you're one of those people that you don't care, don't buy the K processor. If you buy a K processor, know that you have to buy a cooler. It could be a liquid cooler, air cooler, whatever way you want to go. And know that just because it's overclockable doesn't mean you have to overclock it. And know that it's already overclocked out of the box. It's 10% faster than the exact same model that doesn't have the K designation. So it's not a waste of money to buy a K model processor and not overclock it. When you overclock it, what you're doing is you are instructing the computer to push this harder than it was designed by the engineers, and as such, it often voids warranty. It can cause damage. It can cause the computer to become unreliable and to blue screen. And all of that in the name of performance is weird to me, because a computer that crashes isn't... A computer without reliability makes the performance worse. I'd rather have a slower computer that was reliable than a faster computer that crashed all the time. So in the box, we've got just one little thing here. Now this little chip, like I say, several $100s for this one little chip. And then let's zoom you in here on the board. There we go. Right here is where that's going to go, and you'll see there's a cover and with a warning on it. And the reason that warning is there are lots of little pins underneath. Let me show you. You see that? That is 1,151 little teeny tiny pins that are very, very easily damaged. When I say very easily damaged, what do I mean? What does he mean? How does he define easy? Well, how difficult would it be for me to damage those pins? Well, look at this board. Same socket, right? Or similar socket anyway. Let's see if I can find the camera. Find the camera, Carrie. Everything's backwards and upside down to me. There it is. See the socket? So much as touching these pins. All I have to do is touch them. If I just lightly drag my finger across, you can actually see damage occurring if I can find the camera. Where is it? Where is it? It's right there. Okay, don't move. Just lightly bringing my hand across it. See what's happening? See how uniform they look? And as I drag my finger. Now, if you are using any sort of a long sleeve shirt that can snag onto these, you're done. It's done. It's out of warranty. This is not a defect in manufacturing. This is something you caused, and you'll have to buy a new motherboard. So, as I continue to find the camera, there, don't do that. Don't do this. This is all unrepairable now. It's done. It'll cost you more to fix this than to buy a new board in America. So, enjoy living vicariously through me as I destroy the socket by touching it. You can clearly see the damage on it now. So don't do that. So this is the real socket. We're not touching this one. All we're going to do is we're going to take the CPU out of this enclosure, which is got a little cutout in the corner, and we lift that up, and you'll see there's two cutouts on each side, and that's for your fingers to hold it by the edges. Do not hold this like a potato chip. Don't touch the top or the bottom. It's not because it's delicate. I can throw this against the wall. It's going to be fine. What I'm trying to do is I'm trying to keep contaminants off of it. And contaminants mean dust. It means oils from your skin, all of that. Also, it protects it from any electrostatic discharge. Because I'm not wearing an electrostatic strap, as long as I'm holding all of the electronic components by their edges, if there's an electrostatic discharge, it has no place to go as far as any of the components are concerned. You'll see one corner of this CPU has a little arrow indicator, which is right there. Right, hold on, focus. Right there, see the arrow? My autofocus is all over the place. And also on the CPU socket, there's going to be an arrow, and it should be, I believe it's right there. The other thing on Intel's CPUs is they have these two cutouts. There's a cutout right up here. This is really hard for me to find this camera. There's one right here, there's a cutout, and directly across there's another cutout, right here and right there. And so what I'm going to do to install this, as I just told you how fragile it is, it's nothing to be really worried about or have any anxiety about. All it means is I'm going to gently place it in. I usually, once you line up the arrows, just line it up and then let it gently down. And it sits, it just rests on top. And you can grab this top by the edges and you can see if you can wiggle. It doesn't wiggle, so it's in the socket completely. Next, we're going to lower this lid down. And you see it's got like a little fork right here, and it's going to go underneath that screw. So when I lower that down, this plastic cover, which was there to protect those pins from getting damaged, this is going to pop off automatically when I lower this lever. So I'm going to lower this lever down, and it's going to go underneath this hook. Now the lever is going to have a lot more resistance because now it's going to compress that CPU down onto those pins to, make that electrical connection to those 1151 points below. So I'm going to see how my hand is? I'm going to just push it down, and we have to keep this little plastic cover because if this motherboard ever has to be shipped in for repair, if we ever take that CPU out, the motherboard manufacturer will void your warranty if you don't have those pins protected. So you generally don't send a motherboard back to the manufacturer with RAM or CPU or any components installed because that's not theirs, they're yours. You would take those components out and you would need to put this cover back on. The good news is the likelihood of you ever needing it is pretty slim if you're buying quality parts from reputable manufacturers. But there's also, Murphy's Law is alive and well in this business. And well, some people think Murphy's an optimist, so. All right, just keep all that in mind. So this and this will all go in the motherboard box with everything else we've got left over. That's all there was. I mean, it was a lot of me talking, there's a lot of me explaining why, but as you can see, the actual action of what I did was very simple. It took just a few seconds, and there was no force needed, and there was no struggle, no frustration. Everything should fit just like a glove, and if it doesn't, you're doing something wrong. So don't force anything. Slow down, take a breath, take a look at it. If you're frustrated, walk away for a little while and come back when you're refreshed. Next, I guess we can put the RAM in. Now, ASUS is kind of weird about which RAM sockets they want us to use. Here we've got, let's see. Here we've got 4 RAM sockets. These 2 are black, these 2 are gray. So they want you to use them in pairs, separated pairs. Now on most ASUS boards, they want you to use sockets A2 and B2 first, which in this case are going to be these 2 sockets right here. This side, on some motherboards, this side doesn't open. You see how these open and close, these little retention brackets? This side on some motherboards don't open because if you had a graphics card in here, it would interfere with the ability for these to open. So on this side, on some motherboards, these do not open, so don't try and open them if the board you have is designed this way. This is our RAM. The customer's gone with Corsair Vengeance DDR4. That's 2 16 gig sticks of RAM for a total of 32 gigs. This is 3000 megahertz RAM, which is far more than this customer needs. Again, if you're not overclocking, you don't need overclockable RAM. On the other hand, the RAM was a good price and it doesn't hurt to have it. So I'm going to grab my knife here again and we're going to open this package up. And I want you to see everything you see on my channel is real. Everything is live and real at all times. So there are times, quite often, I make mistakes. And it's important that you recognize that even professionals make mistakes, but they don't give up, they don't get frustrated, they don't quit. And I'll show you how I solve those mistakes. There's nothing about pride or ego here. This is about education. Here we've got the 2 RAM sticks with heat sinks on them. There they are. And these heat sinks are a safe place to hold the RAM. You don't want to touch the exposed, what they call gold fingers. Keep your fingers off the keep your fingers off the fingers. Here is the RAM module, and you can see I can just hold it just like that. There's no anti-static discharge to worry about because it would just be hitting this heat shield, this heat spreader. And corporations in the computer industry, they like to protect their logos from any sort of scratching. So watch for little bits of plastic that have to be removed because if they get really hot, the plastic can start to give off an unpleasant odor. So I'm going to peel off the protection on the logo because God forbid, this can all get scratched. Everything can get scratched as long as their logo is okay. They're happy. Now, if you're not sure which sockets to use for your RAM, always refer to your motherboard manual and it'll have a little diagram there. So what I'm going to do is the RAM has got a key in it, and basically it's a notch, and then the socket also has that notch as well, and that makes it so you can only install the RAM one direction. I can't flip it the other way, it won't go in. Again, if you're struggling to install your RAM, you might have it backwards. So what you want to do is you want to set the RAM into its socket with the proper orientation, and it just goes straight down, and it should align. Right? Just straight. No force, no pressure. Once you verified you're in the socket correctly, use your thumbs and push down one corner and the other corner. Doesn't matter which corner you start with, one at a time. Don't try and push them both in at the same time. Then we're going to repeat the same process with the remaining module. So again, I'm going to pull this plastic off of here, which just drives me crazy. I'm sure they could save a little bit in the manufacturing process by removing that. No one would ever care. Well, nobody who has an impact in their financial success of their company would care. So let's turn this around and let's get it lined up in the socket correctly. And then once again, one corner and the other corner. That's it. 32 gigs of RAM is installed, our processor is installed, and then all of this boxes and stuff, that can all go right over there. Same with this. Here, take that. All right, now we have an M.2 drive to install. Now, for whatever reason, this is installed in an OEM package. This is not the kind of retail package a consumer would normally see at Best Buy or in the retail store. This is more the type of packaging that businesses get that build computers. It's often referred to as OEM. It doesn't have all the flash and pomp and circumstance of retail packaging, which adds cost to whatever you're doing. So here, once again, everything's real. This has never been opened before. You see I'm cutting the tape. And inside is the retail package. All right, never mind. Forget what I just said, because that's the retail package right there. This is an Intel SSD 6. This is one terabyte of storage on a device the size of a stick of Wrigley spearmint gum. And this is a very aggressively priced NVMe drive. Non-volatile memory express, NVMe or NVMe, is much, much faster. And the memory technology in this is called QLC. And I don't want to get too nerdy on you. QLC is kind of the low bar for NVMe capable drives, but still faster than any SATA-based drive. So, and priced similarly. In many cases, you can buy this drive or a drive similar to it that's slower for the same or more money. So why would you? Why not get the faster? It's not the fastest drive, but if you've got X amount of dollars and you're getting a terabyte of storage, then it is the fastest drive for that amount of money and that amount of capacity that's available today. So why wouldn't you? Now, I got more tape to cut. And right here, let's see what we got. There we go. Empty box. Instructions. I'll keep those to go in the motherboard box. And there's our stick of chewing gum. It's very crunchy, so I don't advise eating it. This is the part. This is it. This little tiny thing. I just want to show you. Hold on a minute. My favorite part coming up. You guys are ready for my favorite part. All right. Just take this out of here. Let's throw that over there. You've heard of a thumb drive? Well, let me introduce you to a gum drive. Why do I call it a gum drive? Because this is a stick of chewing gum. So, do I have a 1 terabyte of storage, or do I have a stick of chewing gum? The chewing gum is very tasty. I don't know how many bites per second I get out of it, though. I'm hilarious. It's gold right there. All right. I want to pick that wrapper up because it probably smells like chewing gum, and I don't want my dog to eat it. That was worth it for the gag. Now, where's it going to go? On this motherboard, we have a couple of places we can put this. There's a little socket right here. I probably should change the camera, right? There's a little socket right there. And then I believe there's one underneath this heat sink right here. And indeed there is. So we've got one here, one here. Now, ideally, I want to use the one under the heat sink. The hotter these get, the slower they go. So we want to keep it nice and cool. One of the worst locations, in my opinion, that you can place something that needs to remain cool is between the two hottest components on your system, which are going to be your graphics card and your CPU. So to sandwich that right in between there, it's not ideal. I mean, the engineers have obviously worked it out that it's going to be okay, but I have no doubt this location away from the heat will be this location. This location. Where am I? Where am I? There we go. That location right there. Let's zoom out a little bit. That location right there is preferred, but I need to make sure that that location supports the NVMe protocol that this drive uses. That is in the documentation. Let me show you. Here in the box, we'll pull the manual out. And as we flip through the manual, we will see the specifications of the storage, which here says, audio LAN storage. Right here is storage instruction. And it says, both sockets support NVMe SSDs. But they both don't support SATA. Only socket 1 supports both PCIe, also called NVMe, and SATA, and the other one is PCIe only, which is number 2. So which one's number 1 and which one's number 2? Well, there's going to be a diagram, and I don't want to visit your bathroom if you don't know the difference between number 1 and number 2. But anyway, there's a diagram here, and it isolates, and it says on the diagram, a little drawing, there's little words right there, that say this is, they're far too small for me to read. I'm getting way too old for this, guys. I need my glasses. Where's my glasses? I need my glasses to find my glasses. All right. You don't know what it's like. Well, some of you do. Some of you do know what it's like to go through your whole life with perfect vision, and one day you get old. Okay, so in this case, this right here is socket 1, and this is called socket 2. And the manual says that on the storage side, that socket 2 supports PCIe mode only. Don't you love the jargon, the technical jargon that we use in this industry? For me to tell you that this slot supports PCIe by4 NVMe SSD. What did he say? What does that mean? It means it's fast. So that's the one we're going to use. So equally, we could use either one, basically. Either one will work fine for NVMe. And let me get a screwdriver. Screwdriver. I don't have a screwdriver. Come on out. Let's see if this will work. I'm going to start by removing this heat spreader. Again, the jargon and the terminology that we use often have numerous words that mean the same thing. You may hear words like IHS, which is internal heat spreader. You may hear heat spreader, heat shield, heat sink. We're all effectively saying the same thing, though there are technical differences. For average use in communication, it's all pretty much, when you hear them, they all pretty much mean the same thing. On the bottom, there's a thermal pad here to help with the heat transfer. It's got a little piece of protective tape. That's to protect what? Contamination, like dust, dirt, debris, oils from the skin. So we're not going to take that off until we're ready to put it back on. We want to keep that as free from contamination as possible. Now, what happens if we take it off and we get dirt and dust and fingerprints on it? Nothing. Nothing happens at all. You can still use it. It just won't work as optimally. And it may not be anything that a human being could notice, but maybe some software might throw your temperatures by a degree or two. People tend to be very anal about the cooling of their computer. It's almost like a technical hypochondria epidemic, but it's not as big of a deal as you think. But do your best. Just do your best to avoid touching it. So therefore, don't take the tape off until you need it. And then we need a screw that's going to go in here because we need a screw and a standoff to go in here. There's 3 different places because these SSD drives that can go in can be this big, or this big. And so they're measured by width and length in millimeters. So this drive right here is measured its model is a 2280. That means it's 22 millimeters wide and 80 millimeters long. And so if we just set this in the socket, we can see which of those standoffs it's going to align with. So it's aligning with this one right here at the very end, right where my finger is. So the very last standoff is the one we want to use. And then these 2 standoffs are what the heat shield goes into. I'm seeing a weird reflection on the camera, so I think there's some plastic that needs to come off of here because it's driving me crazy. Remember I said there's plastic all over? Here's a piece of plastic that needs to go. This is only for shipping purposes. You are not intended to run your computer with that plastic on. Will it hurt anything if you do? Well, right here with this heatsink, if this heatsink gets really hot, this plastic could start to melt and emit an odor. And the other thing is when you sell the motherboard years from now to the next person, they peel it off and it's like brand new, so you did them a really great favor. So who are you building a computer for? You know, there's another piece of plastic here. Again, your computer will run with that plastic on. It may emit a weird odor, but it is advised both in the instructions and from me to you that you take that plastic off. All you're doing by leaving it on and keeping it nice is keeping it nice for the next guy. So it's yours. Enjoy it. Time for some Coca-Cola. All right, I'm just stopping here for a little breather. Hey, Marty, we got you in there? Mine has no heat shield for my gum drive. Yeah, most of them don't. New motherboards are starting to come with them, standard. You can also buy them if you want to from companies like EKWB. The reason they don't come with this is because they're not required. Just because you can do something doesn't mean you need to do it. You can put really nice hubcaps on your lawnmower. I don't know why you would, but you could if you wanted to. If you said, well, my lawnmower doesn't have hubcaps, if it was important to you, you could go get them. Most people are obsessed with the heat of things that run when they're building their own computer. If you're of that mindset, if you're one of those people that considers yourself a technical hobbyist or enthusiast, to me, that's an identifier right away that you're not a professional. And the reason I say that, it's not an insult, it's just that pros don't do that. When you're working, every time I worked at Intel or APS or SRP or the government, anytime I worked, never once did anybody have any concern over how hot something was. Nobody ever asked that question. We never looked into it unless we were trying to solve a problem. We never even considered looking at it. Because what you're doing effectively, psychologically, is you are creating a problem where there isn't one. So my advice is, I'm all about education, but I'm also about don't fix it if it ain't broke. Carl Curtins contributed €4, and in fact, I should check and see what other contributions I've missed. Carl, thank you so much for supporting the channel. Everybody, welcome in if you're just joining. Tony Wallows contributed $1.99, and Planet Cryos has contributed $5. Would you like some peanuts and Cracker Jacks with that pitch? He's referring to my baseball pitch. I don't care if I ever come back. What a great song about baseball. I don't care if I ever come back. I couldn't have said it better myself. Randy Kendricks contributed $9.99. Oh, I think I talked about that one already. Also, going back to Planet Cryos there, that user also has his own YouTube channel. And be sure and check his content out and subscribe to him if you enjoy his content. Where is Madi? I don't see Madi in the chat room anymore. But this is Madi's computer. Ah, there he is. There's Madi. How you liking your build so far? What do you think, Madi? How you feel, buddy? Madi's excited. Can you imagine how you would feel if you were Madi right now? He's getting to see his computer built, and he's there watching it, and this build is made possible because Madi is permitting me to film this for you guys, for the benefit of me educating. He is allowing me to do this out of his own kindness and generosity. So when you guys just give him a thank you or an acknowledgement in the chat room, and let him know that, you know, it's people like him and people like you guys that are contributing that make all of this possible. It's not just me. There's no sponsors here. You're the only sponsor. So if you want to fast forward past yourself, go right ahead. Red Dragon's contributed $2. He says, one on me. Hey, thank you, Red Dragon. Thanks for supporting the channel, of course. Okay, I think I need another soda. Where am I from? You know, people are from Michigan. We don't say soda. We say pop. Need another pop. Couple shouts out to friends of the channel, folks like Jesse Kirk, Colin Hilton, Peter Laycock. I'm going to feel really bad about this. Winston Ang Lu, Tony Wallow, regular contributors. Thank you guys so much for being my friend, for being a part of a positive community. Positive communities on the internet are few and far between. I would say they're rarer than diamonds. And the value of this channel with the human nature value of this channel is unlike anything I've ever seen on the internet. And it's because we found each other. So let's hope we never lose each other and we keep this community growing strong. CCTV user said we say pop in the UK too. Person from Australia said they say Coke, even though they don't necessarily mean literally Coke. Would you like a drink? They'd say, would you like a Coke? I go, you say yes. And they go, what kind? What do you mean, what kind? A Coke. I mean, do you want root beer? Do you want orange? Do you want, well, that's not Coke. That's an interesting cultural difference there. Ah, yes, a couple names, a couple of friends I've missed, Ben Fitzpatrick as well as Ben DeCure. And Steven Bernstein and Steve Bokar, you guys, all you guys rock. And there's not probably, I know for a fact there's at least a dozen other people that are, for some reason, my mind is blanking out. But all those people that you see in the chat room whose names are in blue with a wrench, I consider all of you my friends. And all of you who don't have your name in blue with a wrench, as I recognize you as a regular on this channel, and as I see that you are kind and supportive to the community, I will recognize that and make you blue as well. When your name is in blue, you don't have to do anything. It doesn't. All it does for me is it identifies, because there's so many of you, it helps me remember who's a supporter and who's a good community member versus who's unknown. So if I don't see your name in blue, it means I just haven't recognized you quite yet, but don't give up. You just keep being a good person, and it's just a matter of time before I recognize you. And sometimes people have to point it out to me too. Sometimes people have said, you know, hey, I've contributed and supported and you've never made me blue. And then I feel embarrassed and I immediately remedy that. Just so you know, I'm not perfect. And sometimes I need those little reminders. CCTV users contributed £2. He says, that's for a pop, Carrie. Thank you. And Thomas Carter has contributed £2 as well. You guys rock so much. And one of these days, I do hope to make it to the UK. It is absolutely on my bucket list. What else do we have here in the chat? I want to remind you, you can get great free advice from friends here in the chat room. And of course, verify any advice you get on the internet with other sources, right? There's a great support site for free. If you have any technical questions when we're not live or you're looking to get a second opinion, you can go to www.techguy.org. And they'll answer questions on hardware, software, heck, probably Tupperware, Windows OS, Android OS, Linux OS, ISOS. I don't even know what that is. I just made it up, but there's probably somebody there who knew something about it. Samuel Ramos has contributed $10, and Bearmick has contributed $2, and Juan Velez has contributed $5. You guys, thank you. I always intend to make sure that anybody who contributes financially gets the acknowledgement they deserve for that, the recognition they deserve for that, and thank you for making this an amazing community. Let's get back to work, shall we? Switch back to camera 2. Please switch to camera 2. Control room. There you go. Camera 2. Don't mind me. I'm going to pretend like I have a camera guy and I'm talking to the studio. Oh, this is very routine for me, so I have to do something to keep myself entertained. Okay, in this bag right here, there are, Irving T has contributed €2. Irving, another familiar friend of the channel. Irving watches us from France and has been a longtime viewer. Patrick Rousseau, I also just recognized Patrick. Patrick, another longtime viewer and supporter of the channel. Thank you, Patrick. And again, just because I'm not mentioning your name, it doesn't mean you're not a supporter. It's all happening live and as I see it, okay? So please don't, if I hurt your feelings, let me know. I don't mean to. Let's see, I need some scissors. This is something you want to be real careful about, because if you lose these screws, they are difficult to replace. Not impossible, just difficult. So you'll see in the bag, I've got, let's see if I can zoom in here. No, other way. Yeah, these screws right here. And there's 2 sets, so there's 2 sockets, right? We're only using 1 socket, so we only need 1 set, and then the other set we'll put away. We don't want to lose them. They are very, very tiny, and you'd have to probably go online to order them, and so your build won't get completed until you get the proper part. You don't want to look around your house for something that'll work. That's a bad idea. They're specialized, very small, not common, and just be careful you don't lose them, and you won't be in that position to begin with. So let's zoom that back out, and so right here, this is where we're installing, hold on, let me find it on the camera. Right. I have to tell you, turning this so you guys can see it is not the same as where you would place it if you were doing it. I'm actually, in many cases, doing everything backwards. It's like having to write something exactly backwards because it's on a window. It's not the way you would normally write, but you're doing that for the benefit of everybody else. And you might go, wow, that guy's handwriting is really bad. Well, you recognize that he's writing backwards. Most of us don't have that talent. So for me to work upside down and backwards kind of throws me off a little bit. So bear with me as I try and align everything appropriately. Okay, so this is where I'm going, right here. That's my goal. That hole is my goal. So what I'm going to do is I'm going to take this drive. It only goes in one way. You'll see it's got a notch in it, so it can only go in one direction. And it's got a little groove cut out right here. That's where the screw goes. And what I do is I put this in on an angle, sort of like that. You can also kind of come in straight until those gold fingers are gone. And you'll see it kind of looks like a little springy diving board or something, right? So that's where the screw and the standoff come in, which are over here. Let me grab them real quick. Now, as I mentioned, where we want to place the screw is right here on the board. So one more time, I just inserted that because I got a little ahead of myself. We're going to put the little standoff in this position right here. And again, this is hard to film close-up subs because you can see how much bigger my hand is than the part I'm working with, and so my hand is going to cover it up. So just bear with me as I get that started. Now that little standoff, like any other standoff on a computer, is 5 millimeters in diameter. It requires a 5 millimeter socket. And I have a special tool dedicated just for this. This is a ratcheting screwdriver with a 5 millimeter bit attached. And that way I can, you know, hey, righties, tighties, lefties, loosies, we want to tighten this down, but not over tighten it. Just get it snug on there. And then we're done with this tool. It can be put away. Now I can place this back into its socket. Again, no force is needed. That's going to align right with that standoff I placed, and using the little screw that was in the bag with the standoff, I'm going to use a magnetized screwdriver. It is critical that you use magnetized tools when working on a computer so that you don't drop the screw and potentially scratch the circuit board in any way, or drop the screw into somewhere where it'd be difficult to get out of, like I showed earlier, the inside of the power supply. So there was this, back in the 80s and early 90s, we used to use floppy disks, and they were magnetic-based media. And they told you to keep magnets away from your computer because you could erase or corrupt any magnetic-based media from the disruption of the other magnet. We don't do that anymore. This isn't this isn't the 1900s anymore. We're in the 2000s, right? This is not the 1980s or the 1990s. So why would you follow rules from the 1980s and 1990s? Why would you? But there's plenty of people on the internet that still advise you because that's how they were taught. And when they were taught correctly at that time. However, it no longer applies. Here we can now finally get this tape off of the thermal pad. And then we're going to gently set this down. Hello. Which way does it go? I've already forgotten. Why does this not look right? Was it like that? I think it was like that. Ooh, it's a little gooey. That's sticky. It looks right to me. Does it look right to you? I think we're okay. Now, the screws that I took out of there are pretty unique. I've never quite seen screws like that before, and so they're unique to this motherboard and this design. And we'll just get that started. And we'll get the other side started as well. And now we can just go ahead and snug these screws up now that everything's lined up properly. And that's a really good design from ASUS on that. You can see there was no risk of shorting anything out. Like some of the other heat sinks that I've seen for M.2 drives, they go into like a hinge, and it's very easy to get the hinge underneath into the socket and short everything out. This is a much smarter design and very easy to install. Unfortunately, it doesn't have any sort of positive locking. However, you can kind of tell from the pattern that's painted onto it which direction it should have gone on, and I didn't notice that till just now. Unfortunately, I was thinking this cutout here, I thought it overlapped, but it doesn't. Big contribution just came in, 1,000 Swedish krona, which is approximately 110 US dollars. That's very generous. Who just did that? That came from Frederick Lundholm. So Frederick, wow, thank you so much for your generosity. You know, Frederick's a frequent contributor here, and certainly a big shout out of a big thank you to Frederick for showing his generosity here. I really appreciate that, and going to have to dedicate a show just to Frederick. He's equivalent of a sponsor at this point. Woohoo! Frederick, Frederick, Frederick. All right. That's all there is to prepping the board except for the heat shield, right? We've got to put the heat sink on. Now there's lots and lots of heat sinks and lots of obsessed people that are on the borderline of needing medication, in my opinion, with regards to the overkill of this fascination with computer heat. You know, the engineers, they know what they're doing when they design this stuff. You don't have to second guess them, unless, of course, you have an engineering degree. You probably are out of your league. But if it makes you feel good, I don't want to stop you, but I do want to alert other people that those people often tell other people how to do things, and they say it with such a form of authority. Sounds good, but many times what they're talking about is ultimately irrelevant and negligible. So with regards to the difference it makes with computer performance and reliability, as long as you're within the heat range that's designed by the engineers, you don't need to go any cooler than that. There's no benefit to it. Only the extreme overclockers, and those people already know what they're doing, so they don't need to watch a channel like this to see how to build a computer unless they just like to police videos or they have nothing else better to do. I know some people just enjoy watching the videos, and that's great. The more the merrier. But I want to just emphasize that when we talk about cooling, when we talk about thermal compound, there are people online that exaggerate the importance of this because they don't have a academic education in the field, and it is frustrating. It is you as a viewer, you have to decide for yourself who you choose to believe. But my best advice to anybody skeptical is to actually measure the difference between what I'm telling you and what somebody else is telling you. And I truly believe that when you actually put the effort forward, you will confirm everything I'm telling you to be true. Until you actually do it, you shouldn't believe anybody if you are skeptical. If you wonder, is this the right way or is this the right way? Is this one better than this one? The best way to find out is for you to experience it. If I tell you the chicken tastes better than the steak, how do you know that you and I like the same things? You're going to have to, if you're curious and you really want to know, there's only one way you're going to have to know. Take a bite of that chicken and you take a bite of that steak. And what you like is what you like, and it's not wrong no matter what anybody says. And what you like may not be what I like, and that doesn't make me wrong either, right? We don't have to argue. Just because people agree with each other doesn't mean they're right, and just because people disagree with each other doesn't mean they're wrong. Okay, so here we've got the CPU, right? And we need to put a heatsink on there because this is the hottest thing. This will hit 100 degrees Celsius within seconds. So we want to make sure that we don't get that temperature that high, because at that point the CPU starts to throttle down and save itself from burning up. Back in the day, a CPU would overheat and just crack in half. They were made of porcelain because of that. I'm sorry, not porcelain. They were made of ceramic material because it has such a high heat tolerance, just like remember the space shuttle? The whole bottom of the space shuttle was covered in ceramic tiles to help prevent the space shuttle from burning and incinerating and returning into the atmosphere. And so now things have changed a bit, and now the CPUs, they're intelligent enough to realize they're getting too hot, and they start to shut down parts of the CPU and slow down. You may never notice as a user. If, for example, I had a client call me because they were running out of space on their hard drive, and my job was simple: replace the hard drive with a bigger one and clone all the data. But while I was in there, I saw that their heatsink fan had never been plugged in. And I said, have you noticed any problems with your computer apart from the space issue? Nope. How long have you had it? Over a year? Well, potentially this thing has been unplugged for over a year. And there's no damage whatsoever, and the customer never even knew. So people that go and they monitor their temps like they're obsessed with it, and other people never look, at the end of the day, the reality never changes. The temperature is what it is. So here is my favorite cooler right now, and it's funny because never heard of this company. This company reaches out to me. Would you like to try one of our coolers? They're not paying me. They're just saying if you want to try it. I go, yeah, I'll try it. So they send it to me, and I'm very skeptical because I never heard of them before. So I'm like, it's probably junk, but try and keep an open mind. Just not so open that your brains fall out. And I fell in love with it. It's like my favorite cooler right now. It's from a company called Scythe, and it's called the Mugen 5. Let me just show you the box right up here. This is the Mugen 5. And I love everything about this. If I was going to design a cooler, it would be just like this, only cooler. See what I did there? All right, so this is a box that has all the parts we're going to need for the install. We're going to just set that here. Then we've got the fan, right? And you'll see a little piece of metal sticking out right there. That's part of the cooler. We're going to take this out. Rest of the box is empty. Once again, anytime we're dealing with moving heat from one place to another, we want to keep the surfaces clean. So there's a piece of, there's a sticker here that again keeps off the contamination, skin, oils from skin. So we don't take this tape off of the bottom until we're ready. And you'll see it's a little offset more to one side than the other, right? Why do I like this cooler so much? What's different about this cooler than other coolers? A number of factors are involved. The main factor for me is the ease of installation. Third-party manufacturers that make coolers, there's hundreds to choose from, literally hundreds. And if they all did it the same, they'd start suing each other or requiring them to pay royalties. So it forces them, out of greed to come up with their own unique mounting mechanism, or other companies less greedy. Look, that's one way of looking at it anyway. They pay royalties to use somebody like Asetek's mounting mechanisms. Asetek is generally, one of those patents that you have, frequently is paid by cooler manufacturers, especially liquid cooler manufacturers. So not only is it a good, smart design, it's easy to install, almost effortless, really, compared to other coolers of this nature, or for that matter, any tower air cooler. And it's fairly priced, in my opinion. It's not expensive, it's not cheap. This runs about $50 in the US. This is the Mugen 5 Revision B, and I cannot get over how easy this is to install. Now, in this box, here's the thing that I've never seen done before. There's a company called Noctua, and everybody seems to fall over Noctua with this sort of weird cult-like behavior. And while the products they make are good, they're very, very expensive. And even they don't come with the type of quality that's in this box. Specifically, the free tool that they include. Noctua gives you the cheapest free tool. You might as well throw it away when you're done with it. This one, on the other hand, has a real, honest-to-God screwdriver inside of it that you can use to build your computer with. It's magnetized. It is not a throwaway tool. This is a tool you would go to the hardware store and buy, and it would be probably somewhere around $8 or $12 for this. And they're giving it for free with the cooler. So come for the cooler, stay for the screwdrivers. And we're going to need it. It's important you have to have a very long screwdriver for this. And then there's also, well, I just dumped the bag into the box. That was brilliant. In the box, got the documentation, the back plate, thumb screws rather, some washers. There are these wire hangers. Now there's 4 wire hangers. It's 2 per fan. This cooler is going to have 1 fan on it with the option to add another fan. So for example, again, for people unfamiliar with how these things work, they gave us a fan. And the fan's going to go on one side, and it's going to push air through the cooler. If you want to, if you're one of those cooling obsessed people, you can buy another fan, put it on the other side, and so they've included a few extra parts to do that if you choose to for added expense as an option. And you would put the fan on in the same direction, so all the air is moving in one way. As one fan is pushing air through the heatsink, another fan is pulling air through the heatsink. It was funny when we were in the chat the other day and someone said, does it suck or does it blow? Fans don't suck or blow. If you talk like that, we know that you don't, you're not going to have that question on your quiz at school, okay? It's going to be, it pulls air or it pushes air. It's still funny, but it pushes air. So anyway, what we want to do when you look at a fan and you wonder which side is the side that's pulling air in and which side draws air out, it's very easy. You'll see on this side of the fan, you see how that logo spins in the middle? This is the side that sucks air in. On every fan, go look at a box fan at your house. They all work the same. The side that spins, well, I shouldn't say that. The side that spins right here, this is the side that's going to draw air in. The side that has the support brackets, and as I turn the fan, you see that logo doesn't spin? That's always the side the air comes out of. It's going to blow air out this way, right? It's going to come in here and go out there. Sometimes on the shroud around the fan, on the frame of the fan, there may be arrows pointing to the direction the fan turns. So there'll often be 2 arrows, one pointing the direction of the fan and one pointing the direction of the airflow. But just visually inspecting it, you shouldn't need that sort of spoon feeding. You should be able to look at that and go, well, clearly this is spinning, this logo is spinning, so that's where that's the air going in. And this side, the support bracket side, where the center doesn't spin, is always the side the air comes out. We good? So when we install this heatsink, we're going to put it on the motherboard, and we want it so that the fan is going to draw air out towards the back. This is going to be the back, and we want the air blowing towards the back. We want all of our airflow in our computer case to all move in the same direction, because if you have air buffet against each other, your cooling goes right down the toilet. So we want to make sure all airflow comes in from the front and out through the back. Very simple, very uncomplicated. And we're going to put the fan on last. What I need to do is get some thermal compound, because we're going to talk about another common internet myth about the application method used in thermal compound and how much it really doesn't matter. I use a different method based on years and 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 years of experience. You don't have to do it the way I do it, but you also don't have to support the computers I build. So I have a rubber glove. Let's see here. The doctor is ready to see you now. Now, this is a brand new rubber glove. You know, I can tell. You know how I know this is new and clean? That's how. That is so wrong. But it's hilarious. It's a brand new rubber glove. We're going to use it one time. We're going to throw it away. Why am I wearing it? Well, I need to spread thermal compound on the CPU. Now, some people prefer to use what they call a dot method or a P method, or they lay a little pattern out and they squish it down. They talk about air bubbles. They talk about all kinds of nonsense that absolutely doesn't apply. And what I do is I lay the thermal compound down onto the CPU and I spread it with the glove to ensure that there's a nice even coating, just like a coating of paint, so that the entire heat shield is covered. If you just lay a dab of thermal compound on there and then you squish it down, how do you know you've covered the whole thing? If your dab is too big and you squish it down, it oozes out all over the place. It's a mess. So the only way I know that this entire heat spreader is covered is to paint it myself. And you don't have to make it too thick. You definitely don't want it to be see-through. And for that, they give us this tube of thermal compound. And I'm realizing just now I'm not quite ready yet to put that on. The first thing I'll leave the glove on because we'll just work with it. First thing we need to do is use this back plate. Now this back plate is made of metal. A lot of third-party manufacturers of coolers don't use metal, they use plastic, and the plastic over time can get brittle, dry, and crack. This will never happen with this. You'll see that there's a bit of rubber right, let me show you, right there. And that's because you never want metal to touch metal on a computer or any circuit board. So that's how you know this is where this protection is. That's the side that's going to go against the motherboard. And there are 3 holes, and that's because it covers 3 different types of sockets. So you use the hole that's appropriate for your socket. You go, well, how do I know that? Well, not all instructions are bad. The instructions are also another thing Scythe has done correctly with their cooler. They are very easy to follow, lots and lots of pictures, and yet the instructions aren't this thick where you're like, oh, how can you tell me it's easy if the instructions are that thick? This is 1 page, double-sided, that covers 3 different installation processes for 3 different sockets, which is pretty impressive that contain that much information on such a small area. So if we look, this, for example, this page is dedicated to installing on the AMD sockets. This page over here, this is for installing the socket we've got. And this page over here is for installing on an Intel socket we don't have. So out of all of this print, the only thing we need to pay attention to is this side here. And this side here, in the very first box here, it's showing us which screws to use. See the numbers? It says 775, use that hole. 1366, use that hole. And 115X, use that middle hole. But you don't have a 115X, you have a 1151. Yeah, that's what it says right on the box. It's a socket 1151. The reason the X is there instead of a 1 is if it was a socket 1150, 1151, if there was a 1152, 53, 54, 56, 57, 58, 59, the X is a variable. And that variable means any number that comes after 115, X is that number. And it will work. That's what they're telling you with that, with the way they use that word X after the model number. So this tells us we want to use the middle hole right here. And it's telling us that we want to use, let's see, let's look at it together. We're going to put some standoffs in the holes around the CPU, and they're going to go into those holes there behind the motherboard. All right, so let's do that. You know, I think I'll take this glove off because I'm not ready for it yet. Let's clear some of my workspace. It's getting a little messy. All right. This is a little difficult to film. I'll do my best to show you. These third-party coolers can be, it's easier when you have a cameraman. One of these days. One of these days. So here, I've got a number of different standoffs here. And again, there's a couple different standoffs depending on the socket you're using. And for this socket, we want to use the standoffs with the longer screws. The standoffs with the shorter screws, those are for the other Intel socket or for AMD, I'm not sure, but we're not going to use those. So these are the ones I use. These are the ones I'm not using. You can see the difference in the length and the size of the standoff. Like if we take this one and compare it side by side right there, see the size difference? So I want the bigger one. And the rest of those, just set those aside for now. A couple of contributions just came in, so let's give a couple shots out here. Christoph Esch is watching us from Germany. He's contributed €10. He says there's cookies for the dogs. And Tony Wello, again, has contributed $1.99. And thank you both, again, for supporting the channel, of course. Let me make sure I haven't, looks like I might have missed some here. Soren Rasmussen has contributed 20 Danish krona. Thank you. I think you're the only one I missed. If you contributed and I missed it, please let me know. Seth Harris contributed $2.99. I think I missed you, Seth. My apologies. Again, if I've missed your contribution, you can shout at me in the chat over and over until I see it. I need eyes that I can watch the chat and watch what I'm building and have a cameraman and make sure the sound is going out. And I just don't have that many eyes, ears, and hands. So please understand that. All right, so what I need to do now is I'm going to pick the motherboard up and tilt it over onto its side. Peter Brooks has just contributed £1.99. Thank you, Peter. Thank you. All right, here on the back of the board, this metal plate, this is the CPU socket support. You'll see it's got two screws there and one there. You can see they're poking through. The reason I point that out is oftentimes on these brackets, they also have matching holes to line up so you know which way that goes on. So these two holes line up with those two nubs. Right? Pretty easy. And then, remember I said we're using that middle hole. That's the one we're aiming for. That middle hole is our goal. So I'm going to just flip this over like so. This is not awkward at all. And that right there, that's one of the holes I need. Should line up right there. Just like, nope, no, not gonna do it. Let's go. Okay, I'm just spinning that with my hand, getting that started so it's going through. And then I'm gonna go do the opposite corner just so everything stays aligned so I don't have to struggle so badly. Don't tighten those screws all the way down. It will make it difficult to get the others in. I'm trying my best to avoid touching any of the metal components on the board, other than like, you know, this frame right here. You can touch the frame. If you should accidentally touch something you shouldn't touch, don't worry, it's probably gonna be fine. Just try your best to avoid touching it. I have had people email me with so much anxiety. Oh my God, I touched it. What's gonna happen? What do I have, a crystal ball? I don't know what's going to happen, but it's probably going to be just fine. I'm just advising you to avoid the scenario so you don't have to wonder what's going to happen. And I didn't even go in the right place. I didn't mean to go here. Where I wanted to go, I wanted to go from here to here. So I just made my life harder. That's okay. I can still do it. That starts that one, and then there's just this one last one right here. Now that they're all started, now they can be tightened down, and you can see they've got a groove in there, so you can get a big screwdriver if you want to, and you can tighten those bad boys down, because this is important that these are secured very strongly to the back plate, because there's going to be a lot of pressure on it. But you can tighten these down so far that you crack the motherboard, that you crush it. So don't go all gorilla on me. Just take them to a point where they don't want to turn and stop. Don't try to think you're sealing it against water or something, because that's a good way to cause damage. Don't use an electric screwdriver on these. You can snap them right off. You can shear the screw right off of it. So if they turn easily, and remember, as you turn them, it starts to bend one way or the other, and then other screws can loosen. So you see I keep going around. Always best to work opposite corners so that everything tightens evenly with no warpage, with even coverage. And that's probably way overkill at this point. It ain't going nowhere. So we're good. Do you like my proper term of English? It ain't going nowhere. All right, now we have some brackets here. This is what you hear me toying with. We have two sets of brackets. I believe one set is AMD and one set is Intel, but I'm not exactly sure, so I'm gonna go back to the instructions and show you what I'm gonna look at. Contribution just came in from Rami Hermes, Australian, $20. Thank you. Thank you to Rami. And says at least, Raphael says, at least you have a stationary camera and will not have to use a hand to hold it with. Yeah, well, it wasn't always that way. All right, so going back to our documentation, as we look at which brackets we need, I'm looking at the instructions and it's showing, where are my brackets, just so I can give you an idea. I have two different kinds of brackets that are in the box. I got this one that's kind of curved, looks like a parenthesis. I got this one that just is straight and it's got a little dent or bend in it right there. So as I look, I can see I need to use these straight ones. This may come in use later. So for right now, I want to use these two. And it wants me to remember that I can put these on this way or this way. You've got to pay attention to these little details. Remember, this is an incredibly simple process if you pay attention. If you don't pay attention, that's where you're going to get confused. So you need full focus on what you're doing here to realize how simple it is. So here you can see on the diagram that the bracket goes along the same line as where the retention lever was that I lifted and closed on the socket. It kind of goes in the same line as you see they show the RAM right here. So I'm going perpendicular with the RAM, going in the same direction as the RAM. I'm not going this way, I'm going this way. And I'm looking at what orientation it has, and it shows the orientation is these, the little buckle in it goes up. It doesn't go down, it goes up. So in other words, it wants this installed this way, not this way. This little dent in here, right here, that should go up. And then you would want these screws facing inward towards the CPU, not away from the CPU. Little teeny tiny details like that. Incredibly simple and incredibly simple to miss. So what that means is, switching back over to this camera, what that means is it wants me to put this on like this. And so grabbing these screws that came with the case, with the cooler, and we can use the screwdriver even that came with the cooler. Magnetized, right from the manufacturer, nice. That's going to go right there. Again, we're not tightening it down. Not just yet. This is going to go here. Now this is an easy one. Now you may be saying, wait, that's an easy one? It seems like it's taken you a long time. Well, I'm first of all taking my time. I'm enjoying my build. This is not a competition. It's not a race. And secondly, I'm not really struggling to get any of these parts installed. With other coolers, you may see me struggle a bit more with regards to getting the cooler or the parts therein lined up properly. So what I'm doing right now is I'm trying to align the slot with the hole beneath it. And it's a little bit of a challenge because I might have this screw right here in a funky position. I think it needs to be more centered. I think it needs to go on the inside. think. Wow, that screwdriver really holds that screw well. You see me struggle to get it off? That's great. All right, let's try on the inside, just like that. And with both of those started, I can tighten those down. So that's what you need to pay attention to, that little bump is facing up, that these screws are facing inward towards the CPU so that when we put the other one on, it is symmetrical. You understand symmetry? That means it's going to be the exact same facing the other way. So in other words, these two screws again face towards the CPU. This would be wrong. This would be wrong. This would be wrong. I can spend all day explaining to you how to do it wrong, but I'd rather spend less time and just show you how to do it right. So there's that. And then same thing again, we want to use the holes towards the inside, which in this case is right there. Just get it started. And then other side. Right there. Bada boom, bada bing. Those don't have to be super tight. Just get them a little past snug, you're good to go. You with me? Let's see, let's switch back over to main camera. There we go. Now we're able to place the heatsink on top. Now, does the heatsink go on this way or does it go on this way? Well, keep in mind that we've got a big fan that's got to go on here, right? And we've got RAM sitting right here. So if we put this on backwards, we can make it work, but it's certainly getting in the way of the RAM. And when we add a fan onto it, it's going to further encroach upon our RAM. So if we flip it the other way and we place it on like this, you can see just how much space there is now for both the fan and the RAM to have adequate room. It's pretty easy to tell how that goes on. And all we're going to have to do is apply our thermal compound and tighten down that screw. And then there's a screw that's way down deep inside of here that we're going to go right down inside of that. And then that's how we tighten it down. So this is the point where we can apply our thermal compound, because that's the last part of what we have to do now. And that means it's time to peel this little plastic off of here. And it's unfortunate, if there was one criticism I have, it's the way that they did that. You would never know that that was there. It doesn't have like an orange pull tab that says remove. It doesn't even, you actually have to read that very carefully. And it should be orange or red. It should really draw attention, and it should have a little piece of it sticking out like this, so that when you go to install it, you can see it and go, why is that sticking out? Now that I've removed it, I want to make sure I don't contaminate it as much as I can. So let's get to applying thermal paste. That's going to require a new glove. I want a clean glove. The gloves you see me use are not rubber gloves. These are nitrile gloves. They make them in numerous thicknesses measured in milli-inches. These are 3 milli-inches. These are, I believe, a medium size. They're very inexpensive. Do not build a computer with rubber gloves. If you must wear gloves, wear nitrile gloves. Now, I need to come up with a new joke. Fits like a glove. All right. in the box that came with the components to install the heatsink, they've included a little tube of thermal compound. You are not supposed to use the whole tube. They've given you extra so you can make a mistake and wipe it clean and do it again if you need to. Let me show you. Let's go back to the close-up and let's just put a dab onto the CPU, sort of like this. Okay, you can see lots and lots still left in this tube. This stuff is messy and it's hard to get off your skin. Now, you don't have to do it this way. You don't have to do it the way I'm showing you. You also aren't going to get a call from a customer if there's a problem with the computer that you didn't build. So you're free to do it any way you want. I'm simply showing you the way I do it, which is a clean rubber glove or a nitrile glove. And I'm going to paint. This is where I become Bob Ross. I'm just going to have a little happy thermal paste there. Little happy, there's no mistakes, just little happy accidents as I got a little bit over there. That's okay, it's still nice and clean. And we want to make sure that there's adequate and even coverage across the entire surface of the CPU heat spreader and ensure that we cannot see or read through that thermal paste. That's approximately how much you put on. If you put on too much, it makes a big mess and it actually can impact the efficacy of the cooling. If you use too little, it can affect the efficacy of the cooling. Probably better to use a little too much than a little too little, but best to put on the right amount. There is really something that amounts to human judgment here and not precise measurements. It should just look similar in that it's painted. It's painted. Now I can, let's go back up. I can show you how messy this is. So here I've kept the mess minimized to just one finger. And this gets all over everything and it's really hard to clean, right? So I'm just gonna fold the glove in on itself to keep that mess inside, and then I can safely dispose of that. Now we can apply the heatsink. We're not going to put the fan on it yet. Remember what I said about the orientation earlier? That's how I know to put it on this way and not this way. We want the fan to blow air through the heatsink and out the back of the computer case. And so we'll just set it gently on top and line those screws up right like so. Let's bring it back to that camera. We're going to use the enclosed screwdriver. Let's see. That's a pretty good angle right there, isn't it? Just come down on this and just start it. Just give it a couple turns and make sure that it's in there. Now do the same thing by placing the screwdriver through this opening on top, and it's going to go through to the other screw, which should also be aligned now with the hole in the bracket, and give it a couple of turns and make sure that it's started. With both screws started, now you can start to tighten down one side and then equally tighten down the other side. And then come back and do this side again. So again, just like putting a car tire on, you don't want to go around in a circle, you want to alternate back and forth so that it tightens evenly across the entire surface. If you do it wrong, what will happen? Nothing you would probably notice. It simply won't cool as effectively. How would you know if you've never used one of these coolers how much it should cool? So you'll say, well, my computer's not overheating, I guess I must have done it right. Not necessarily. You could be having a warpage between where the surfaces meet, and you may never know, and your computer may never overheat. That's how tolerant computers are to heat, and why people being so obsessed with it doesn't make a whole lot of sense. Now, here you'll see the screwdriver is going right through the center of the heatsink. Most people don't have a screwdriver that long, certainly that's also that width to fit through that hole. So just can't believe how cool it is. Did I just say cool? That the cooler manufacturer has included such a quality tool. That's very unusual. Like I say, even Noctua who is widely regarded as one of the best, doesn't give you quality tools. They give you throwaway tools. I think I have landscapers here. We're going to take a little intermission and allow the landscapers to do their job. And we'll come back, I will put the fan on, and then we can install the motherboard into the case. So everybody just take a little break, get yourself a drink, use the bathroom, whatever you have to do. Continue to chat with each other in the chat, and I'll be back here in just a few minutes. Stay tuned.